we'd like to tell you more about how you remember neighbors basically. All right, on to MapReduce.
Hey guys, thanks for coming here. And my name is Harish, and I'm a data architect here at Openspan. And I'm going to be talking about Elastic MapReduce tonight. So we've been using Elastic MapReduce for the past 3 or 4 months here at Openspan, and we've worked through a lot of the learning curve, we believe, at this point, and we've got nailed down some key elements of design and some key elements of architecture. So that's probably going to be my focus tonight, as well as actually a step-by-step tutorial on how to get your first Elastic MapReduce job running. So just before we begin, I'd like a quick show of hands as to how many people here actually use AWS. Cool. So I think most of us are acquainted with AWS at least. And how many of you actually use Hadoop in any form or flavor, whether it's AWS or Cloudera or whatever? Okay, cool. So I didn't originally set out with. How many of you are aware of Hadoop or have at least experimented with it or have a general knowledge of what it works like and that sort of thing? Okay. So all right. So we should probably begin, I guess, with a brief introduction to Hadoop and what it does. All right. So what about MapReduce? Are you familiar with the paradigm in general? All right. Okay. So I guess we just begin with an introduction then. So let's begin with some Hadoop essentials. So it's basically Hadoop is it's a distributed MapReduce. It's a way of doing distributed MapReduce, and what that is that it's primarily applies to data sets which are too large to fit on your computer on a single machine. So Hadoop distributes your data in an available manner across a cluster of machines, and then distributes computation which applies to this data across the same cluster of machines, so that various separable parts of your data set are processed in parallel and across multiple instances, across multiple machines. So it's basically a parallel computation mechanism or framework, so to speak. And that's it in a nutshell. And it depends on programs which are coded according to the MapReduce paradigm, which is that there are two parts to your program: a map part and a reduce part. And I actually don't have a strong tutorial on MapReduce here as part of my slideshow, but I encourage you to look into it afterwards, because it's a pretty cool paradigm and it's a good way to parallelize your tasks. And so Elastic MapReduce, or EMR, is the AWS hosted Hadoop, and it just takes away a lot of the cluster administration overhead, a lot of the management, the logistics, the reporting, the diagnostics for error handling and so on. It takes a lot of that out of your plate. You don't have to set that up. It's just you can, as I'm going to demonstrate shortly, you just use the AWS console to get jobs up and running, and you just point it at data which is stored in the Amazon S3 service, and you're ready to go pretty much. So if anybody's ever tried setting up a Hadoop cluster, you pretty much know how painful the process is and getting everything lined up. But this makes it really easy, and it provides a secure environment to do it. Above all, it takes care of all your networking issues, and that sort of thing. So let's get started, I guess. So this is kind of network diagram of what it basically looks like. So this is AWS, and this is the Amazon Simple Storage Service. Are you guys familiar with S3? Yeah, cool. Okay, so we are basically storing our data in S3, and we're running Elastic MapReduce jobs on top of data in S3. And so this is a virtual private cloud, which corresponds to your secure environment where all your instances lie. And this is the public subnet inside the virtual private cloud. It's connected through an internet gateway to the internet at large because it needs to access S3. So basic architecture looks like, and that's how AWS has it implemented. And this is your actual Hadoop cluster within everything. Is that clear to everyone? So please stop me and ask any questions if it's not clear to you at any point. And of course, we'll have a Q&A at the end. So, everything fine? So now we'll just go back to our demo. Okay. So I just did some preparation before this meetup so that we could just get everything going directly without having to set up anything much. This is a S3 bucket for the EMR. Inside I have a directory for an AWS EMR demo, and I have a basic word count MapReduce program. So those of you who are familiar with MapReduce probably know this is the first and sort of easiest example or demo example which comes up very frequently in articles of MapReduce, and it basically counts the number of words in a set of documents. And this is the data here. I'm not sure if this is open in the browser, but I'm going to try. So that's what it looks like. It's a line separated bunch of words in a file, pretty raw text, and it's just for demo purposes. And that's I just have two files of the same sort of data. And I have the MapReduce program here. We can go into the code later if you guys like, which I'm just going to leave it out for now. Collectively, what the program does is it distributes the data that we have in the data bucket, the data directory, across nodes in the EMR in the Hadoop cluster, and then it sort of counts up the number of what it outputs is a word and the count of the number of times the word actually occurs in the data set we have. Is that clear? Okay. So now we'll just go back to our thing here. And I started out the cluster previously and tried it out, so I'm just going to. This is the Elastic MapReduce part of the AWS console, and you have a bunch. You can create your cluster here, or you can clone an existing cluster if you have one. So I'm just going to clone an existing cluster. Yes. So this is. Sorry, please. I'll just take it. So you can name your cluster whatever you like, and there's something called termination protection, which is basically a switch to disable accidentally turning off your cluster or shutting down your cluster by mistake. You want to enable logging, and which is basically system logs and Hadoop logs and so on and so forth, that obviously you want to analyze if something goes wrong. So you set the log folder location to some S3 location, so I just set it to the logs directory inside the 33 bucket in this case.
What's S3 in?
Sorry?
Why S3 in?
Oh right, yeah. So the S3N and S3 is two different ways that you can actually use the Elastic MapReduce system. And what S3N means is S3 native, where it's stored in raw S3 format. Whereas when you say S, it's a little confusing, but when you say S3, that signifies layering HDFS over S3 for the purposes of the EMR cluster. So one of the benefits, I would actually encourage you to look it up later. But basically, there's a 5 gig limit in S3, I believe, for files in standard S3, and if you say S3N, that applies, and if you say just S3, it doesn't apply. It's It's a little confusing. Yeah, that's the basic key points. If you store, if you say just S3, then the file name applies, and if you say S3, and it also applies. Yeah. I think I got that right. Sure. So, you want to enable debugging, and that provides your logs and other error messages in a more useful manner on the AWS console. Then you set up a bunch of tags if you want to tag the instances. So EMR actually starts a bunch of EC2 instances with all the Hadoop software required installed on it and everything running. It provides you with SSH access if you want. And those you can tag those individual EC2 instances with any key value pairs that you want over here using this. So I just set the owner to be my name and the name of the instances to be AWS demo. So you can use this for like billing purposes and so on and so forth. The next thing we can do is software configuration. And you have two choices for Hadoop distributions. You can use the standard Amazon Hadoop distributions, or you can go with MapR. We just use Amazon here at Openspan. And you can select a bunch of AMI versions. So the AMI versions are AWS AMI versions, and they come installed with various Hadoop versions. So 3.1.0 has Hadoop 2.4.0 installed. So that's the one we're going to use for this demo. It's the latest version. That's what we use with Openspan in production. So, you can also install some additional Hadoop-based applications which you may have heard of, like HBase, Pig, Impala, Gangia Hive. We're just going to leave it out for the purpose of this demo, but you can certainly do it and play with it. Okay. So this is the VPC in which you want to bring up your EMR cluster. So typically this would be a client VPC or whatever whatever your model of usage of AWS is. Just go with one of the VPCs, and inside the VPC you need to select the right subnet, which is the subnet which has an internet gateway attached to it, so that the EMR cluster can download and install stuff from the internet and also access S3. So here's these are instance types for the master, the core, and the task nodes of the EMR cluster. And so you can see the description here. The master instance is the sort of name node of the Hadoop cluster, and the core instances are the data nodes. The difference between the core and the task instances is that the task instances run jobs only, and the core instance also provides HDFS storage. So you select the EC2 instance type of the master and the core nodes. For the purpose of this demo, we're just going to leave it at M1 large, but in production we actually use M3.extra large, this one here, and it works pretty well for us. I think it's got about 15 gigs of RAM, and it's what we use. Another feature here you can do is you can request port instances for your EC2 instances. And you can, trade on the spot market just like you would with any other EC2 instance. So I'm going to leave that out just so that we actually have instances to work with. Spot pricing can be a little weird. The next thing we do is we set up SSH key, and this will enable you to actually SSH to the cluster if you require it. And which is pretty useful if you're prototyping code and so on, and you need to quickly look at logs, and you need to analyze it and make some quick changes in code, say, and just try out various things and that sort of thing. It's pretty useful to have SSH access. And you can these flags here will allow other IAM users within your organization or this account to access this cluster and see this cluster. So you can.
You said task servers only run jobs, core servers run jobs and provide storage.
Right, yeah.
Do you have to have task servers?
No, you don't. Actually, for the purpose of this demo, we left them out.
I didn't use them.
Yeah. So yeah, I think here at Openspan, we've started we don't really use the HDFS too much, so we just store everything S3. But so I think I would like to actually experiment with just going with task nodes and leaving out core nodes. And I wonder how that would affect our pricing. So that's something we need to work out. But yeah, good question, thanks. Yeah, we don't actually require class nodes, but I think we require it, maybe at least some core nodes, but I'm not sure. Cool, so the next thing is the IAM roles, and we're just going with the EMR default role for the purpose of this demo. And that should pretty much allow all kinds of access to S3 and other EC2 instance creation and this and that within this usage account. Next thing we come to is bootstrap actions, and there's a bunch of them we can add, and these are often very crucial in configuring your Hadoop installation to behave in an efficient manner and to actually get the desired results from your Hadoop cluster. It's pretty important actually, and I'm going to go into this in detail later. But basically you have 5 options here. Configure Hadoop, which you can use to set various parameters in the MapRead side XML file and the yarn side XML file. You can configure daemons that Hadoop uses, so you can set the memory limits that the daemons can use and so on. You can also I think this applies to the lower versions of Hadoop, but you can sort of set a flag which says to Amazon, configure this for memory intensive purposes. The runif bootstrap action will execute bootstrap actions only on certain kinds of nodes. So you could, if you wanted to perform a bootstrap action on just a master node, for instance, then you could use the runf command. So just to, I think I didn't actually say what bootstrap actions are. So bootstrap actions are steps that are performed before the Hadoop, while the Hadoop cluster is coming up and before your job is executed on it. So if you want to install additional software, if you want to configure Hadoop in a certain way, you do it as a bootstrap action before your job actually starts executing. So it's a very flexible way of configuring a Hadoop cluster, especially if you use the custom action. And what the custom action does is you can actually provide a location to a bash script file, and it will execute the bash script file on each and every node in your cluster. So you can use that to pretty much do anything you want and configure your Linux box in any way you want. It's really powerful, and this is actually what we use, because what we do is we run Ruby MapReduce jobs on our cluster, and we need to install Ruby and all the gems that come with it, and we actually use this to do that result. And the last step finally is to actually configure the job that that we want to run in the Hadoop cluster. And I'm just gonna so what we do is we add a step and we go with streaming program, and it shows up like this. And we kind of edit it to all the various settings in it. We just name it what we want. We specify the mapper reducer, the names, and we give it an input location, which is the input to the S3 job. And this is the same input data location I showed you earlier in the S3. And an output data location where the output of the job actually goes to. We also provided some arguments. Actually, this is like you could actually just do this if you wanted. Let's see. Provided with an S3 location to the map part of your MapReduce program, an S3 location to the reduce part of your MapReduce program, the input data location, the output data location, and any other arguments that you want to provide. You can these are sort of usually you want to provide the Hadoop options and so on and so forth. So if you're using a custom jar in your Hadoop box, if you want a custom multi-output format jar or something like that, you can specify that node here. Then
What?
we should say,
Question on that.
sure,
Those are Python scripts, correct?
yes.
Does it support other scripting languages or what?
Right, so we're actually using Ruby as a scripting language. And what you need to do is you need to specify bootstrap script. You need to write a bash script which installs Ruby and all the gems you need. And you need to run it as a bootstrap action before you can run your job. So it will support whatever Ubuntu XYZ that the underlying OS has installed on it from before. So now Ubuntu and Linux, actually this is Red Hat Linux now. And Red Hat Linux has a Python distribution on it. So it works. But with other programming languages, as you know, if you need to specify a specific version of Python, for example, or if you need some other scripting language, then it may not have it. And you have to install it as bootstrap action before your cluster executes the MapReduce job. Okay. So yeah, it's pretty flexible in that sense. You just specify in bootstrap action what you want on it, and then you're programming whatever language you want, and it'll work.
Does it have to be Dash?
Yes, I believe it has to be that. Yeah. I mean, you could of course like. You could write a Python script, right, and have a shebang on it and make it, I think that should work also. I'm not completely sure. I've never tried it personally.
I'll bet it just does the shebang at the top and just runs.
Yeah, if you have a shebang on top, it should just run.
Do you get access to the cloud of it? Can you pass in cloud of it? Do you have access to pass in values in cloud of it? Or do you want to use Chef, for example?
Now, okay, I'm not sure. You'd have to ask Adam about that actually. He's the more, the DevOps person, so I'm not sure about that. I've never actually used Chef for this. I'm not sure how to do it. It's a good question. And I think it's something that we should look into. Thanks. Yeah, I haven't used anything else apart from Bash to configure these. So we just hit save and just check to see everything's okay. Yeah. Just hit create cluster. And that should start our job for us. It is really that easy. And so this provides a bunch of stuff to the AWS console. You can monitor it, all kinds of parameters that you want to observe. Whatever it is, yeah. Okay. So you can see here that it's setting up the debugging first, and then it's going to run our streaming program. And it has the log. Logs tend to take some time to get created. While it executes, let me show you what the logging looks like on our old cluster. Yeah, here it is. Okay. So this actually, it collects all the logs from all your Hadoop instances and your nodes into the logs directory that you specify, which is an S3 location, and it presents it all in a pretty usable and user-friendly kind of interface. So you can look at whatever logs you want, like your standard out, your standard error controller. You can also drill down and see all the different jobs that are executed. So these are all the reduced jobs, these are the map jobs, and you can see attempts of all of them. And you can see logs from each of those attempts. So it's basically like every single log you need and everything you need to debug your program. Pretty exhaustive set of stuff, that's it. Okay, let's go back to our cluster and see if it's done. Oh, it's still starting. Oh no. Okay. It still says provisioning, so that means it's still getting these EC2 instances from, it's still requesting these EC2 instances to come up. So maybe in the proceed with our presentation and let that keep going. Are there any questions anyone has so far?
For now, you had, let me just try to summarize what you had explained.
Sure, sure.
It's like you had 2 EC2 instances and
Right.
you were trying to install EMR on that.
No, not quite. So the EMR is provided as a service.
Yes, by
And yeah, and what you do is you just it's basically you start off with the concept that I can create a cluster. You no longer create EC2 instances specifically. You just say, okay, I want a cluster, and then it asks you various things like what do you want your cluster to be called, where do you want your routes to go, how many nodes do you want in your
So
cluster.
did you just create a cluster?
That's right. Yes.
Okay, you created a cluster on 2 EC2.
That's right. Yes. On EC2 instances, and all you need to specify is the type of the EC2 instances and how many of each that you want. So that's you just I guess you just cease to think on EC2 level and you start thinking at a cluster level.
Okay, so you have set up a Hadoop cluster now.
That's right.
Yeah.
That's right.
Question.
Thanks. Yeah. Please.
Once you set up the cluster, can you schedule it? If I have some batch.
Absolutely. So that's a good question, and obviously you don't want to run through this whole process every single time. You want some work done. So what you want to do is you want to set up. What we do here at Openspan is we use the Elastic Data Pipeline service of AWS, and that enables you to specify data sources, data sinks, and processing tasks. So as a processing task, you select an EMR job and you configure it. So that will, and then you create a data pipeline and you forget all about it. And that's going to run a daily batch job or a weekly job or an hourly job or whatever, however you configure it on your data to process it to the output. So we use a different AWS service called Elastic Data Pipeline to schedule these jobs.
Okay. Also, when you're setting up the cluster, there's some additional Hadoop application you can install, including
Right.
HBase. In case you want to run a MapReduce job and insert records to some HBase table,
Absolutely. Right.
where are you going to store that table? The record, the H file. Where will it be located?
So, I think the assumption is that initially your data files are stored in S3, right? And then you install a Hive in your cluster, and then you point your cluster saying your data source is here. So, I think when you run a Hive script against the cluster, it just takes the data from S3 and uses it. Regarding inserts, so an insert would mean that you don't actually. So I have a question. So do you mean an insert into the?
I was talking about the HBase. So HBase,
Yeah.
the file, the storage is in the H file, right?
Yeah. Right. Okay.
Right. So when after I run the MapReduce job and get some process some data, get some aggregate
Right.
record, and then I want to insert to the HBase.
Mm-hmm.
Where will that the HBase file located?
So there are two options you have. You can either use S3 to store as the underlying store, or you can use HDFS, which is on your cluster. So,
But will the HDFS still be available after the job's done, or?
Again, that depends. So there are two ways to use EMR. But the first way is to run, pass and go jobs like this, as in you process some data and you shut the cluster down after you're done, with your basic data store being in S3. The second way that you can use EMR is in the more traditional style which you're referring to, which is you bring up a cluster and you keep it running for a year or whatever, and you keep resizing it or something like that, or you clone it. So in that case, in the second case, you would use HDFS on disk. Disk-based HDFS is your storage, and if you insert to HBase, then it would be stored on disk inside those nodes in the cluster itself, and not in S3.
Do they let you mount EBS on it?
Adam, do you want to take that? Do they let you mount EBS?
They use instance stores, or what's the default data store on this?
I'm not sure about that.
For the EMR instances?
Yeah, for the HP, the Hadoop file system nodes, test core servers.
I'm not sure.
Because I don't know the answer to that
So
one.
we default to instance store,
assumption is that you keep the cluster for the duration of processing. That's probably the majority of the use cases that we see.
And then you have an output.
You use a mechanism, as Harish mentioned, like a data pipeline to start the cluster when you need it, and you shut it down.
And that's working storage essentially, and then you output it to
Right.
a long term.
So you persist the data into S3, or you hand the data off from EMR into
Right.
Redshift or something like that to persist the data in
Right.
for additional things. Now, we do have the other use case too, as Harish mentioned, where you have very long-running clusters. You know, people never shut them down, right? So there you actually rely on the distributed nature of HDFS, right, to be able to resize the cluster underneath it and make changes to the footprint of it and still have the data persistent in the HDFS. So you have both of that, right?
They handle that for it. They just handle that and it covers for you with the.
Correct. So you do get the best cost savings though if you are very agile with the cluster, right? If you can bring it up through processing and bring it back down.
Does data pipeline handle starting and stopping clusters for you?
Sure, yeah.
One thing I'd say about the data pipeline that we've run into so far, though, is if you're having multiple team members look at the data pipeline, one member that instantiates and creates it, the other team members are having problems actually viewing it. So if you have if Harish is going to create the data pipeline, it's going to be his pipeline and only he can view it. So if he is going to if I need to look at it, that's a problem. And we made Amazon aware of this, and they said they're working on it. We actually have one account that's in beta that others can view some of it, but they can't. We can't view. We don't have a full view besides the person that's actually created it. So just if you're going to use data pipeline, if you create it, it's going to be your data pipeline, and so you can't tell your junior team member, hey, go take a look at my data pipeline. That I think it's coming down to.
Yeah, so that's been worked on. I mean, obviously you could decouple it in a way of where you use generic IDs to create pipelines in that multiple people can access, right, from an IAM
But then in my cloud trail, I can't see who did what.
Sure, yeah. So, I mean, it requires some orchestration. So we're aware of that.
Yeah, they've got auditing and all kinds of things.
Right.
Cool. So while we were discussing all that, it looks like our trial actually finished. So we can go in here. Yeah, hopefully, yeah. That's our output directory. And this is our familiar looking MapReduce output. Now just yeah, we're gonna download some.
You can select them all.
What's that?
Can you select them all inside the directory? Inside the
Oh, right, yeah,
inside the bucket.
that makes sense. Yes, thanks.
Actions and go to actions and download.
Nope.
Oh, whatever, I'll just go with the standard option.
This would want to do that.
output is like it's a set of word counts. Word Atlanta bitwise, bar appear 3 times, food 4 times, range 2 times, Openspan 1 time, etc. So that basically shows us that our prototype EMR job is actually working. So just carry on with our presentation. We've done this, we've done this, done this, steps, done this. Okay, so these are some basic job design approaches or job design parameters that we run into here at Openspan. And these are also generic stuff which apply to Hadoop in general, not necessarily just Elastic MapReduce. So we need to be really careful with how we store the input data, which means the compression scheme and the serialization format. So if you're aware of how Hadoop works in general, it's usually a good idea to allow for your data to be split up into 64 MB or 100 MB chunks. It's just very optimum for the way it works. And usually you would want to select a compression scheme and a serialization format which facilitates splitting that up in that way. If you can't store each file as a 64 MB file. Of course, if you can store your file as 64 MB or 100 MB or so, in that size range, it works really well. Similar with the output data, you may want to turn on compression. So if your output data is very large and if you want to write it very quickly to avoid all the network overhead. The last thing you'd want to do is, this is another thing that we ran into, which is if you want to, we reached a period where our S3 read-write costs increased a bit. One of the other parameter you want to minimize is the number of S3 reads and writes in order that you keep your cost low. And one way to do that is to batch up your data as much as possible so that the absolute number of reads and writes goes down. So troubleshooting EMR jobs, I think I just walked you through that where we kind of went through all the logs and the logs from each single job and each single attempt of each task inside each job. So you can actually do that on AWS console like I showed you just a little while ago. Then we ran into some configuration parameters we had to tweak and tune for our M3 extra large instances. Basically, we reached a point where each node was only running one single mapper or one single reducer at a time, even though each node had 4 cores, I think, and about 15 gigs of RAM. So it should have been ideally running 3 or 4 mappers at a time, going by the sort of size of data chunks that we had. And these are some of the parameters we had to tweak or tune in our Bootstrap actions, and we just supply them to the Bootstrap actions in a certain syntax which is specified in AWS documentation. And basically you want to set your resource manager memory to a pretty large value, almost the entire RAM, just leaving about 3 gigs aside for the Linux operating system. So yarn scheduler, it should, to each MapReduce job, it should, to each container which runs a MapReduce job, you allocate a minimum of 2048 megabytes. Then each map container gets 3072, which is 1/4 of 12288, and 4 is the number of cores in the computer. So it's kind of if you want to run 4 containers per node, each container on a single CPU, then you want to allocate each container with 1/4 of this total memory. Kind of makes sense that way, right? It's the same for the reduce, and then you want to set up obviously your Java parameters for X and X to be the same as this virtual machine parameters.
You don't have to tell it how many to fork. You just say it figures it out by the amount of memory and then
the number of
by the
mappers
container limits.
The number of macros and producers.
Yeah.
So that's pretty non-deterministic actually in the way Hadoop runs, and it will determine the splits on a number based on
Based on
number.
available.
Yeah. So what you want is what you want to attain is a high degree of parallelization in general. So but the first thing you want to do is use each of your CPUs to run a container, and the way you get around doing that is by setting these memory parameters in this manner. You kind of have this rough formula that you kind of give it, you give, for each node you set a total amount of memory that you can use for Hadoop jobs, and each container then uses 1/4 or 1 by the number of CPUs of the total amount of memory. So it's a bit of tweaking and tuning, and it's not actually very well documented. If you use the out of the box version, it just runs 1 container per node. So it's just wasted time at that point. So yeah. Well, that's all. Thank you all for joining us. And if we're hiring here at Openspan, and this is our previous website, and please encourage you to go there and check it out. That's all. Thanks.